Welcome, Algebra 2 students. We're in Lesson 61, and we're going to be talking about Type B, chemical mixture problems. Now, if you remember, let's talk about Type A for just a minute. Type A was where we had two different containers of the same type of solution. Like, for instance, we would have saline solution, and this one might be 40%, and this one might be 15%, right? And we would pour in some of A and some of B to get a percentage somewhere in between. Like might want to be getting 20%, right? But we couldn't add or subtract any of the individual elements. It was all about mixing what we had in different quantities to get the desired percentage. So type B problems are different. Type B are such that we are going to add or subtract the elements that we want to get the percentage that we want. So we have to understand how to do that, like how to either eliminate or add, and how to write those formulas. So let me write our first problem up here. All right, so our first problem says how much water, so we're dealing with water, must be evaporated from 100 gallons of a 10% brine solution to get a 40% brine solution. So that's our important information. And we're evaporating, so some stuff is going to be leaving. We're going to have a subtraction problem. So let's set up, and we're going to solve for both water. And what is a brine solution? It's water and salt. And when we say 10% brine, we're talking about the amount of salt that is in our water. So we're going to be solving for water. And we're going to go ahead and solve for salt too, just to show you that it doesn't matter which one you solve for, you're going to get the same answer. So how much water must be evaporated from 100 gallons? Concerning the water, if we think about it, we'll have a beginning water amount. And then we're going to evaporate some water, and then we'll have the final amount. For salt, we're going to start with a salt amount to begin with, and then we're going to think about how much salt has to go out, and then we're going to have our final amount of salt, right? Salt final. So let's think about this for a minute. Let's make our buckets. So we start with 100 gallons of a brine solution, right? So that's going to include water. So we start with the total amount. And then we have this bucket here, and this is going to represent what's evaporated. And then the final quantity is just going to be the 100 minus whatever was evaporated, right? So let's think about the salt for a minute. We're going to start with however much salt we have in that 100 gallons, and we're going to think about how much salt is going to go out, right? So we're going to call that O, like salt out. And then we're going to think about the final, and that's going to be our starting amount minus our O, right? Let me put a little. Actually, you know what? I think I'm going to change this. Let me call this, let's just say that this is going to be E. We'll just keep E so we have the same variable on both sides. That'll make it easier for us to look at the problem side by side. So now that we have our formula set up, and if you look, it's the same on both sides. So how do we solve for water versus salt? Well, that depends on the quantity of each. So in the beginning, we had a 10% brine solution. So that means that the solution was 10% salt. So we have 90% water and 10% salt. How do we put percent into a form we can multiply? We put into a decimal. And 90% is represented in a decimal form as 0.9. So 0.9 of this 100 gallons to start with was water. That's our original water amount, is 0.9 times the 100 gallons. For the brine, for the salt, 10% of that was salt. So we know that decimal form of 10% is 0.1. So 0 0.1 times 100 gallons tells us how much salt we had to start with. Now we want to talk about our final amount. So we want to get to 40% brine. Well, if it's 40% brine, right, that means it's 40% salt. And so that means that the other percentage is 60, and that would be how much water. So there'd be 60% water, 40% salt in a 40% brine solution. So we're going to transfer this into a decimal, and that's what our final is going to be, 0.6 times whatever this is. And over here, we're going to do the 0.4 for the amount of salt we want. So now let's think about how much has to be evaporated. We don't know how much has to be evaporated, but we know that it is the water that has to be evaporated. We don't have a coefficient for this yet because we don't know what that percentage is just yet, right? We don't know how much that's going to be. On the other hand, when we think about the salt, none of the salt is going to be evaporated. What's going to be evaporated is water. It tells us that up here, how much water must be evaporated. So no salt is going away. So we're going to put a 0 next to the E because we're not going to evaporate any salt. So that just makes sense right there. So now we just solve. This becomes 90 minus E equals, that's going to be 60 minus 0.6 E. Same thing over here. This is going to be 10. This is going to go away. So it's going to be 10 equals 40. And then this is going to be minus 0.4 E. All right, now we're going to swim our little fish. So we're going to subtract 60 from both sides. It's going to leave 30 over here. And if we add an E to both sides, negative 0.6 plus 1 E is going to be 0.4 E. Now over here, if we swim our 40 over, we get a negative 30, and then we are left with a negative 0.4 E over here. And if you look, the values are very similar. They're just, here they're positive and here they're negative. And when we divide over here by 0.4, we get 75 gallons is what is evaporated. And if we look over here, we get a divide by negative 0.4, divide by negative 0.4. We get 75 gallons is evaporated. So if we solve for either salt or water, as long as we think about it intelligently and we think about what it is that we're doing and apply our proper percentages and decimals, then we'll get the right answer. So actually, I encourage you, if you want to be sure you're getting the right answer, do your problem for both. Solve it for both water and salt, or whatever the two different things are. And if you get the same answer at the end for both, then you know that you have solved it right and you can be confident in your answer. Okay, that's just to show you, we only did this one like this, to show you that you can solve for all of the components and that the answer should come out the same. All right, let's move on to 61.2. Let's clear the page. I'm going to go ahead and type your problem. All right, here's problem number 2. When Frank and Mark finished milking, they found they had 900 pounds of milk. That was 2% butterfat. How much butterfat did they have to add to raise the butterfat content to 8%? By the way, whole milk is a mixture of skim milk and butterfat. That was actually in the book. I didn't add that for a fun fact, but it is. In fact, whole milk has 3.5% butterfat. 2% milk, obviously, has 2% butterfat, and skim milk has 0% butterfat. So, just so you know how to plan your meal there, or your milk in regards to what amount of butterfat you want. So in this problem, we automatically see that we're going to have to add. The last problem we had to subtract. So this one we're going to have to add, and we're going to have to add butterfat, right? So we start with the amount, we're just going to solve for butterfat this time. We're going to start with the amount of butterfat that we began with. It's butterfat 1, the original, right? Starting butterfat. And then we have to add some butterfat. So we're going to call that butterfat added. And then we're going to end up with the final amount of butterfat that we want. So here's our original equation. Now we're going to create our buckets and solve for that. So let's start with our bucket here. Plus, we have a bucket here. And this is going to be our big bucket here. So we started with 900 pounds right here of milk. And then we have an amount of butterfat that we're going to have to add. So let's call this A for add. Pretty easy to think about that. And so now this just becomes 900 plus A, right? Pretty easy so far. So originally the 900 pounds was 2% butterfat. We want to go to 8. So it's 2% butterfat, right? Here. So 0.02, that's how we write 2%. And then we want it to end up being 0.08, 8% butterfat. So now we just solve. Easy peasy. So we multiply 0.02 times 900, we end up with 18, plus some amount added of butterfat, and that's going to equal 0.08 is times 900, it's going to be 72, plus 0.08 of butterfat added. So now we just solve, just like normal. So I'm going to swim 18 over here. I'm going to subtract 18 from both sides because this is the bigger number, and I don't like that working with negatives. I don't think anybody likes that. So when I subtract 18 from both sides, this ends up being 54, right? And when I subtract 0.08, remember this is a 1 right here, from both sides, this ends up being a 0.92. You can use your calculator to do that. And that's the butterfat added. So now we divide both sides by 0.92. And we find out that the amount of butterfat that was added was 58.7 pounds. All right. And so 58.7 pounds butterfat was added to the 900 pounds of milk to give us an 8% butterfat content. So you see, it's all about looking for the keywords to know what this operation is here, starting with your original amount and finding the percentage of that original amount, right? Then you have the unknown that's being added. You have to pick a variable for that. And then the end is just this plus this times whatever the final percentage is that you want. And then you solve. And then that tells you what it is. So we needed 58.7 pounds of butterfat for this. We have, let's see, we have one more. Let's do that one. So I'm going to clear the page. And let me type that for you so that you can actually read. All right, 61.3. Virginia and Campbell had 100 kilograms of a 20% glycol solution. How much of a 40% glycol solution should they add to get a solution that is 35% glycol? All right, so let's start with their formula. Glycol solution number 1, starting amount. And we're going to be adding. So how much should they add? So we're going to add. So we're going to call this glycol added. And they want to get a glycol final amount. So this is the solution. It's just a addition problem. All right, so the original that they had was 100 kilograms. So we're going to put in our buckets 100 here. And then this is going to be the amount. We're going to go ahead and just say, let's just say A for added. It's fine. And then we're going to have, of course, 100 plus A. Right? That's just standard. It's easy peasy. We can do this in our sleep. So they have, to start with, 20%. This is 20%, so that's 0.2. And we know that they have a 40% to add, so we make that 0.4. But what they want to end up with is 0.35. So you see how that works? With this one, we knew what our percentage was that we were adding. We didn't know before, or before it didn't have a percentage. It was all pure of one thing. When it's all pure of one thing, you don't need a factor here, but because we had a factor here that we were adding, we applied it to what is being put into our formula. So now we just do the math as usual. So 0.2 times 100 is going to be 20. This is going to be 0.4a, and this is going to be 35 plus 0.35a. Okay, now we just swim our little fish. So when we swim, this is a bigger amount because it's actually 0.40. That's bigger than 0.35. So I'm going to subtract 0.35 from both sides and leave 0.05a on this side, so I don't have to deal with a negative. And I'm going to subtract 20 from this side and 20 from this side, and that works too because this is a bigger number. So that leaves me 15 over here. Okay. Now I'm going to divide 0.05, or I divide both sides by 0.05. I find out that we need to have 300 kilograms of the 40% glycol solution added, that's the amount added, to get the solution that we want. Let me answer this phone. Okay, I have to apologize. I answered a phone call and I completely forgot where I was. It looks like we finished solving this, that we had 300 kilograms of the 40% glycol solution that should be added to make it a 35% glycol solution. So that would end up making it a 400 kilogram solution when it was over, right? That's what I'm seeing. That is the last example problem for lesson 61. So if you have any questions, please let me know, and I will see you in lesson 62.